over your homework. If you kindly take it out, I'll come by to check it. And okay. Any questions on this? I know it's been 4 days since you probably looked at it. Wow. Or if you just did it last night. So we were looking to find the domain, the range, and then did I give you this on the paper to find me what the value is?
No.
Did it say on your directions?
It says find the domain and range.
Just find the domain and the range?
No, it says
an f of 0. Okay. An f of 0. As I took it out of the book, I wanted to make sure because I didn't put the directions on mine. So just find the value of y when x is 0. And you can take it right off your graph. Stop me if you have any questions on this. When you have a cubing says its domain and range are to infinities. Nine and 10. 10 is a piecewise. This piecewise, this is going out, even though it looks like it stops, it's going on and on and on. If that was misleading. The book just stops the graph, but it's going on and on. It's just because in the book, that was the only size of their graph was like, so I chopped it, but I copied it. If you gave me from wherever you thought it stopped to wherever it stopped, that's fine. Find the value at -3. An exponent. Did this say increasing, decreasing for you? Okay. I don't have the directions on mine. I was hoping I had them on yours. Okay, absolute minimum. If you found this, you needed to find your absolute minimum so that you could see where it was increasing, decreasing. Remember, increasing, decreasing, you're looking for the value of y. But you're giving me the interval over the value of x. Move it up, yeah. That's a little bit of a different concept, and hoping you guys spent a little bit more time in the Algebra 2 Common Core with that. The increasing, decreasing. This is a constant when it stays straight across. There's no increase, there's no decrease. And an increasing, decreasing, find your absolute minimum. You know the difference between absolute and relative? Getting to a little bit harder. Find your increasing, decreasing after you find your relative, max and min. These are relative because they're not the highest point. Infinity is your domain, from negative infinity to positive infinity. Let me know if you have any questions. God bless you. Does anybody know if today's an A day or a B day? A day? I wasn't sure if they changed the day scheme, because when they take the day off the calendar, sometimes they don't go change it. Anybody got that? All right. Everybody okay with finding this again? Be careful when you graph this. You might not see the minimum, but you can, even without changing your screen, you can still find a minimum. It'll find it for you. If you go between those, just pick 2 values and go between those. Anybody have trouble finding this minimum? Okay, you can always change your window and see it a little bit better because it's so small. Remember, again, we round to 3 decimal places. Rule of thumb, 3 decimals. God bless you.
Bless you.
A nice parabola there. God bless
Bless
you.
you.
It's the season of allergies, huh? Massage. No, Chris? Good? Everybody good with the piecewise? Yeah.
For like the first one, can you not use 0? Because it's on.
Well, the thing is with 0, like if you were doing an increasing, decreasing, say I was just doing a regular parabola, and I'll pretend that this actually crosses at the 0, 0. Pretend that's where my vertex is, right? You're coming down here. How do you give me the decreasing? Like, what is my decreasing interval? From here to where? From negative infinity to where? To 0, right? I need that 0, even though it's going to share with this 0. I need to stop at that 0 and then increase. This guy, you need these points because it's not going to stop at the -1. It's going to go to the 0. You're going to have pieces between -1 and 0, right? So it's going to go here with a soft bracket. In other words, this is the part of your domain that went from here to here. It looks exactly like it does over here, right? And then this one is where it's filled in. So these are the points on your graph that you want to make sure you have. One has to be open, one has to be closed for it to be a function. Now sometimes they meet at the same point, sometimes they don't. Do you recognize this? This is your circle kind of. Where is it over here? This had 3 pieces to it. This is your constant piece. Right here, there's your constant. A line, a constant, another line. One of the critical points is a 0 because they both share 0, and another critical point is a 2. An easy way to do your piecewise, again, is to set 3 equations up. Three tables. 1, 2, 3. Go by your domain. Stop at the 0. Give me a couple negatives. Stop at the 0 that has a close. From here, 0 to 2. There's your domain. Open at the 0. Oops, closed at the 2. From here, 2 to infinity. Open at the 2. Just give me a couple. If you need to, put each one of these in your y equal. Put x plus 3 in your y equal. Go to your table and pull out those y's. This one has a constant. This one again, go to your table and pull out those y's. And then piece them together. That's why it's piecewise. And then the last group was finding odd and even. Remember, if it's even, it has symmetry across the y-axis. If it's odd, it has symmetry through the origin. You're going to find, even if you look at your table, you're going to find this rule for even. If it's odd, I have an odd right there, you're going to find symmetry through the origin. That means they're going to stay in the same place, but they're both going to negate. So this point here, whatever this point here is, if this is -1, +2, this point is going to be the opposite, 1, -2. If it is, I don't know if that's the point. But symmetry through the origin just changes the sign of them. That makes it odd. And again, you're going to have to solve it algebraically. Check it on your calc, but solve it algebraically. Just replace the x with a -x. if at the end, if it's easier to do this, take out the -1, because this makes it odd. This has to be the same as the original. If you spot that all the signs change in your expression, that's odd. And sometimes you have neither. And looking at your graph is probably an easy way to verify that. I need you to know how to do these algebraically as well, not just with your graph. Make sure you know how to replace the x and do it algebraically. Yep, absolutely. So all you have to do algebraically is just replace the x with a negative x. So anytime you see x, the best way to do this is just go like this. Be careful where you put the negative. It has to be inside that parentheses. And then resolve it. This is going to stay a positive x squared. This is going to be a negative times a negative is a positive. Now, once you replace the x, is this the same as the original? No. The only difference here is the middle sign changed. It has to be exactly the same as the original to be even. If it's odd, every sign will be different, the opposite. But this is the same, right? This is opposite, and this is the same. Another way to do a negative is if you pull a -1 out of it. It's sometimes a little easier to look at. Is that the same as the original? No. So algebraically, you're just replacing the x with a -x. Let's plug it into this guy. So that happened to be a neither. None of them matched. So this one says this is going to come out to be a negative because it's a cube to an odd power. This is going to stay where that negative is going to cause this to be a positive, 4x. So if I pull out the negative, watch what happens. Isn't that the same as the original? Isn't this one over here all the opposite signs? You can do it that way too. If it has all the opposite signs, or you can pull out a -1 and have it be the original function, then it's an odd. If you graph it, it has symmetry through the origin. So a nice way to look at your graph, if you pull this up, when you do it, is look at your table. Use your rules of transformation. In your table, okay, let me put this in and I'll put one in here. I'll put this guy in. Okay, so if you look at your table, just stick me on my graph because you can kind of see the symmetry here, through here. But if you look at your table, if you pick a point, let's see, -1, 1, and you take the opposites, 1, -1, should be right there. See the symmetry between these two? Oh, my graph is off. Between -1, 1 and 1, -1. Well, my graph is a little off, as usual. I asked them to look at my smartboard, but oh well. Eventually. So all you're going to be doing is replacing the x with a -x. Even inside, in here. Replace this with a -x, and this still becomes the same thing. Because you're squaring this, that stays the same. So if it's the same as your original, you're an even. And confirm it on your graph. You'll see symmetry over the y-axis when it's even. You'll see symmetry through the origin. Okay, so far?
Number 10.
Mm-hmm. Are we good up to here? Let's look at the bottom. Anything before 10? Anything before 10 you want to look at? So 10, you're going to have to replace both of these x's, this one and this one. So it's going to be negative x times 2 square root negative x squared plus 4. So this is going to become negative 2x. This stays exactly the same. So what this is saying is it exactly the same as the original? Nope. This is where factoring out a negative 1 is helpful. If I factor out a negative 1, is it exactly the same as the original? Because remember, there's only one term here. So you did negate that term. These are factors, but it's only one term. So this is a little easier to see if you factor out the negative 1, right? Good? Everybody okay with this? Okay. Now what I thought we would do is spend a little bit more time sketching and describing. When you sketch and describe, you might need that sheet with you that says all the pieces to it until you get used to like all the things you have to describe. I left that separate from the notes because you can just pull it out when you need it. Okay. So let's pull this up. All right, so let's do the first one together. This way you remember how to do sketch and describe. Put it in your palette because you're going to have to sketch it. Remember, sketching, I don't want tick marks there. I want you to sketch. Okay, make me a sketch. How many roots should this have? How many zeros? 4. Which way should it open? Up or down? Down. And both ends are going to be opening down. It should have 4 roots. It should have 3 turns. Let me do this, and we'll do inflection points soon. So you see it should look like this. Does it look like this? Are they both the same size? So it looks like an upside down W. Good. Okay, so first step through. Can you give me the domain? Negative infinity to positive infinity. Can you give me the range yet? To something. Negative infinity to something. So we have to find those somethings. So let's start here. Let's label this A, B, and C. And we'll catch the roots in a minute. If we said 4, we have 1, 2, 3. We should have one more. This right here is a double root. Normally your graphs go through the x-axis. If it bounces off the x-axis at any point, that's a double root. So technically I have 4. 1, 2, 3, 4. Right now we're in real roots, in real number system. We didn't throw any imaginaries yet. So are these relative minimums or relative maximums, absolute minimums, absolute maximums? Absolute maximums. We want to make sure, that they're exactly the same y values, right? They look like they are, we just want to make sure. If one was off than the other, then one would be a relative, one would be an absolute. So if your graph went like this, and it's possible that they can go like this, then one would be a relative, one would be an absolute. So let's check these using our max. So do a max and find me the maximum for A on your graph. Do second calc, give me a max. And if it's helpful, use the cursor or use the end boundaries, whatever is easier for you. On the board, I tend to use the cursor just so everybody can see it and watch it move in here. Find your maximums for both. Remember your rule of thumb, 3 decimal points. And find this maximum. We agree they're the same y value? If they're the same y value, it is an absolute. If they're different y values, one is a relative, one is an absolute. Okay? What's this guy called? What's B called? A minimum? Is it a relative? Is it an absolute? Relative. Because this goes on and on. So B is a relative minimum. Find me your relative minimum. To look at your table for your turning point there, you can do a minimum. Try not to just guess by the graph. Remember, sometimes your calculator does weird things with the 0, such as probably when you do this minimum. These are both zeros. Yeah, if you take that one, Chris, I have another one too. -7, these are just scientific notation. It says move the decimal 7 places to the left, which makes it virtually 0. This says move it 12 places to the left, which makes it virtually 0. So there's your 0, 0. Can you find me the range now? Negative infinity to 4. Hard bracket or soft bracket? Hard bracket, because it stops at 4, right? It stops at 4. Okay, let's do your intercepts. X-intercept is when y is equal to 0. Go back to the original equation and plug in a y for 0. This has to be done algebraically. I know you can find it in the table, but you can confirm it in the table, but it has to be done algebraically. So we're going to factor this. What can you factor out of this? X squared. So this is going to give me a negative x squared plus 4. Here's your double root right here. Oh, sorry. Took them up quickly. Don't forget to do the don't forget to finish the